Welcome to TechPod, where we talk software engineering. I'm your host, Milan, and in our third episode, we are going to talk about software testing and the essentials of domain-driven design. Our guest is Vladimir Khorikov. He is the author of the book Unit Testing Principles, Practices, and Patterns. He is a Pluralsight author and a Microsoft MVP. He has more than 18 years of experience in API development, large and complex enterprise projects, and legacy code refactoring. So, welcome, Vladimir.
Thank you for having me.
Yeah, it's great. It's great to have you. Such a great personality in software testing and domain-driven design. So, let's start with a couple of easy questions for you, I would say. So, can you explain like the concept behind software testing and why is it important in the software development process?
Yeah, well, without actually making sure that your software works, you cannot deploy it to production, or it would be quite reckless to do so. Because of that, we as developers, we employ various practices that help us make sure that our software is working. And the usual way is to do it manually, basically, to just go through the functionality and make sure that everything is working. But over time, people started to develop some automated ways to do so. And unit testing or just automated testing is a good way to make sure that your software is working without actually spending a lot of time on that, because manual testing can be quite time consuming, maybe error prone, because people might not test everything, especially if they repeat this process over and over again. So yeah, that's where unit testing, integration testing, and other forms of automated testing comes into play.
Yeah, and also I would like to add that basically, in order to be a good developer, like you have to also be a good manual tester, because in order to know that you wrote a good code, you have to know how to test it, like what are the test cases, like, and what can go wrong. So
Yeah, you definitely need to keep in mind the edge cases that your software may be in. And test against those edge cases for sure.
yeah, yeah. Okay, so but there are a lot of kinds of basically testing. So what types of testing should developer be proficient in? Like just from a developer's point of view.
Yeah, the most widespread form of testing for developers is unit testing. It's basically when you, along with writing the code itself, you also write tests that cover that code, and there are multiple ways to do so. In the book, I showed that there are basically two schools of unit testing. One is the London school, which is also sometimes called Marxist school. And also there is the Detroit or classical or Chicago school of unit testing. There are some differences between them. And the main difference is that London school usually advocates for using mocks or mocking for most of the dependencies, and the classical school, it advocates for limiting the use of mocks, and we can talk about that a little bit more in depth later.
Yeah, sure. Mocking is a big part of the testing as well. So you mentioned unit testing. Can you like tell us in like can you explain to some maybe younger listeners or maybe not that experienced one, like what would be like unit testing? Like what would you test there and what other types exist, like integration testing and end to end? Can we compare those three?
Sure. So basically, unit testing is, let's say you develop a lot of examples include something simple like a calculator. You develop the code for the calculator, and then you also write unit tests that test that calculator. Or if you are writing some enterprise level application, it could be maybe a user class. And for that particular user or customer, you need to calculate, let's say, the amount of taxes that that user owes on your purchase. That could be another method on that user class that just calculates those taxes. And unit test would be something that doesn't touch anything other than your code itself. So it doesn't go to the database to get all those tax details, purchase details. It doesn't go to the network to get the current, let's say, tax rates through some API. It only focuses on your code alone in isolation from everything else. That would be a unit test. It's in the book I provided this definition. A unit test is a test that tests one unit of behavior, and it does it quickly and in isolation from other tests. So basically, a unit test is a test that you can run in parallel to other tests, and that's because it doesn't. Those unit tests don't share any dependencies between them, and basically, a unit of behavior can be anything. It can be a piece of code that can be fit into one method, one class, or even a group of classes. What matters is that it's a single unit of behavior from the end user perspective. So if, for example, the tax calculation logic involves not just a user, but also let's say the order class or a purchase class, then the unit of behavior calculating the taxes will involve not just the user class, but also those other dependent classes like the order class. And that's fine to include them into the testing scope. It's just you need to make sure that you only test one thing, and that still would be a unit test. It's quite a controversial opinion because, as I said, there are two schools of thought, London School and Classical School. In London School, that kind of test wouldn't actually be considered a unit test. It would be something more like an integration test, because from the London School perspective, if you test more than one class, then you test integration between those classes, and then it's called integration test. Whereas in the classical school, it's still considered a unit test as long as it doesn't touch any external dependencies, any out-of-process dependencies like the database, for example. So integration test, that's a test that goes higher the stack or higher the test pyramid. It's a test that does involve out-of-process dependencies, like, for example, the database. And basically, the goal of those tests is not to test your business logic in isolation. That's the goal of unit tests. But integration tests verify how your functionality, how your code, how your business logic works in integration with other components. So let's say, for example, your application integrates with a database, with some external API. So the goal of integration tests is to make sure that that integration of your business logic with those APIs, with those databases, works correctly. That would be integration tests. And end-to-end test is a subset of integration tests. The line between integration tests and end-to-end tests is a little bit blurry. It's not as set as between integration tests and unit tests. But generally, end-to-end tests is, you can say that they are integration tests that include all out-of-process dependencies into the testing scope. So for integration tests, you can still exclude some of those dependencies, some of those external dependencies, if they are hard to test, or if they are hard to set up, or maybe if you don't own those dependencies. So for example, you can, in integration tests, you can include the database. That's the component that your team owns, but you can exclude the tax rate API, because that's an external API that your team doesn't own, and it's developed and maintained by someone else. Whereas an end-to-end test would include all of those external dependencies, including the database and that third-party API.
Yeah, great explanation. And since you already mentioned your book, so I know that like you have the 4 pillars of a good unit test. So maybe we can go through all 4 that you mentioned.
Yeah, sure. So in the book, yeah, as you said, I basically outlined the four components of a good test, not just unit tests, but all tests. And they are protection against bugs or regressions, as I call them in the book. The second one is resistance to refactoring or resilience to refactoring. The third one is fast feedback, and the last one is maintainability. So basically, let's start with the second two because they are easier to describe, and then we'll come back to the first two. So fast feedback is pretty much self-explanatory. It's how fast your tests execute, and the faster they are, the quicker you get the feedback from those tests, and the less time you spend in on going in the wrong direction. So basically, a bug that is found on the early stages of development is much easier, much less costly to fix than a bug that is found at the later stages of development. So, for example, a bug that you found when you develop your code and when you didn't publish any code to any environments yet is pretty much costless to fix. You just need to fix that bug and that's all. And the same bug found in the QA environment would cost you 10 times more time to fix, because you not only need to fix it, you also need to communicate with the QA people. You need to promote a new version to that QA environment. And the same is true for the production environment. That's usually take even more time to fix than bugs found in the QA environment. That's the fast feedback component. The maintainability component is basically a function of two subcomponents. It's how easy it is to understand the test and how easy it is to run the test. How easy it is to understand the test is basically how well your test is written, how clear the code is, how large your code is in that test. So that's what forms this readability subcomponent. And how easy it is to run the test is a function of does your test work with any external dependencies, with a database, with some external APIs? Because if it does, it means that this test becomes harder to run, because for that test to run properly, you also need to have all those dependencies lined up. You need to set up proper data in the database. You need to make sure that connectivity between the test environment and the external API works fine. So stuff like that. That's the maintainability metric. The first two metrics are, again, they are protection against bugs and resilience to refactoring. Protection against bugs is how it shows you how well your tests, how good your tests are at finding bugs. So it's basically a function of how much code your tests execute, and also how complex or important that code is. Because usually the more critical bugs are found in business logic or some critical piece of functionality or complex piece of functionality. And also, as I said, it's not only important to test your code, but also integration between your code and some other components, some other subsystems like third-party APIs or the database. That's also need to be tested, because you cannot just make sure that your code works in isolation or in vacuum. You need to also test how it integrates with all those subcomponents. And the second metric, or the second property of a good test, resilience to refactoring, is the property that is the most misunderstood in my experience by developers. So basically, this second component tells you how it's a function of the number of false positives that your tests raise when you run them. And a false positive is basically a false alarm. It's when your test says that there is a bug, but there is no bugs in reality in that piece of functionality. And this happens usually when you refactor your code, when you modify the implementation details without actually modifying the observable behavior of that code. So that usually, when that happens, and when the test says that there is a bug, so basically test fails, it means that this test was coupled to implementation details of your code. Instead of just verifying the behavior of your code from the end user's perspective, it verified or checked implementation details of that code. And that's a bad practice, because the more your tests are coupled to implementation details, the more false alarms or false positives they will raise when you refactor your code. And because of that, it will inhibit or prevent your efforts on refactoring your code. And it's important to refactor your code regularly, because requirements change. You may introduce some temporary hacks into your code that needs to be cleaned up or fixed. And so because of that, you need to constantly refactor your code to prevent code deterioration, because code tends to deteriorate over time. Tends to degrade. To prevent all that, you need to constantly refactor that, but to be effective at refactoring, you need to make sure that your refactoring didn't introduce any bugs. And if your tests just basically raise false alarms all the time, they tell you that you introduced a bug, whereas there is no bug in that code, you cannot trust those tests. And because of that, you will not be able to implement refactoring as regularly as needed, because you will be afraid that, basically you wouldn't trust those tests, and because of that, you will be afraid to actually touch anything in your code, because you don't know if you introduce any bugs into that code with your refactoring. So that's the second metric, or the second property of a good unit test: resilience to refactoring. And the first two properties, protection against bugs and resilience to refactoring, they form the metric that I called test accuracy. It's basically the ratio between the number of bugs found and the number of false alarms raised by those tests. So it's a signal to noise ratio. And both of these metrics, both signal and noise, are important because, well, signal is important because that's why you write your tests. You want them to find you bugs. But the noise metric is also important because even if your tests are capable of finding any bugs in your code, if they do that with a lot of noise, then all that signal will be lost in all that noise. Basically, you wouldn't be able to differentiate between true signal and false signal or false alarm. So, and test accuracy of tests, accuracy of the tests that can find you a lot of bugs, but they do that with a lot of noise, also tends to zero because of that, because they generate a lot of noise. That's the gist of these four properties or four components of a good test.
Yeah, I would say that you summed up like basically the essentials of software testing in like 4 pillars. So really nicely said. And I would like to add that throughout my career, like I worked on multiple projects, and I worked with some developers that were just like writing code just to increase the code coverage. So I'm not sure that all developers are aware how important it is to really write good unit tests, to test not just unit tests, any test, integration, any tests that like the project is requiring, just for the maintenance and for later refactoring. So it's really important not to write tests just because of some PM told you so, or your tech lead, team lead, or somebody. Well, to basically enable maintainability of the project itself later on.
Yeah, an illustration of this phenomena that you mentioned is when the organization or the team has a strict requirement on the coverage metrics. So let's say they require 90% or even 100% test coverage. And if your code doesn't fit or meet that requirement, the build fails automatically, and it doesn't allow you to actually merge your change to the main branch. I had experience with that as well, and the most extreme example of that was when in our team, people basically started to write garbage tests just to meet that arbitrary metric without which they couldn't check in their code. And they started to write tests, like, for example, just just put a try-catch block so that it catches all exceptions, and put inside that try-catch block, they put the code, and they don't verify anything. They don't. These tests don't assert anything, and on top of that, they also catch all the exceptions, as I said. So these tests are completely useless. They don't check anything, but they add to the coverage metric, and therefore they help them. They help the team to meet this coverage metric that is imposed on them. So basically, all these requirements to have some specific coverage number, if it is mandatory, they usually lead to bad incentives, because people start to write tests not to actually verify the code, but to meet those metrics, which is a bad idea always.
Yeah, I completely agree. I would say that we as developers need to be more responsible to basically own our code a bit more. Okay, so yeah, I had a couple discussions in the couple past years regarding the naming convention of the tests, especially unit tests. So, and I know that you wrote a blog 2 years ago about test naming conventions. So, what would you say? What is the good name for the unit test, and what maybe convention should we follow?
Yeah, that's a controversial topic, I would say. So one of the most prevalent or widespread convention is to do something like include into the test name the system under test, or the method under test, or the class under test, then also include the scenario under which it is tested, and then the expected output. So it could look like, for example, calculator or tax calculator given zero orders returns $0 or returns zero. Or if we're talking about some, I don't know, division functionality, then it could say that calculator given zero divider returns throws an exception. So stuff like that. And these names are understandable, or they people who develop the code, or developers, they can understand those names or those naming conventions, but it's still not ideal, because it's hard to understand what the test actually verifies with those names. Ideally, your tests, the names of those tests, should convey not what they are doing, or rather, not how they are testing, but what exactly they are testing from the end user's perspective, from the business perspective. So instead of just saying, for example, that calculator given zero divider should throw an exception, it should say that calculator cannot divide by zero. That would be an expected behavior that is understandable not just to developers, but also the users of that calculator, because the users, they don't know what this throw means. And it doesn't necessarily mean that, well, it could mean multiple things, because it's implementation detail. It's basically an implementation detail that leaks to the name of the test itself. And tests shouldn't verify or shouldn't focus on implementation details at all. And the same is for tax calculator. So instead of just saying that this tax calculator given zero orders or zero purchases returns zero, you can say that tax calculator, or rather empty or no purchases give you zero taxes, so something like that. So stuff like things that would be understandable or meaningful, not just to developers, but also to the business people or domain experts.
Okay. Yeah, I completely agree. I like to say that the test name needs to be like in some parts like self-explanatory. So you don't need like basically to write a comment at the top of the test like, okay, this test does this, this, and that. I'm not sure. So just try to keep it short and basically self-explanatory.
Yeah.
Okay, and like we in a couple in your previous answers you mentioned mocking, when to mock and when not to mock. So maybe we can talk about that subject as well. So I
Yeah,
know it's really interesting one.
it's another controversial topic,
Yeah.
and as I said previously, there are two schools of thought on that topic. One is the London school, and the other one is the classic school. And to actually talk about mocking, we need to talk about the types of dependencies, because mocks is basically the fake dependency that you use in tests instead of the real dependency to simplify testing, or basically to simplify testing. So basically, instead of, let's say, testing the database directly, you're introducing a mock or a stub that replaces that database or a third-party API with some fake behavior that is sufficient enough to test some functionality that depends on that database or third-party API. And so, as I said, the London school, it advocates for mocking almost everything. So if we divide our dependencies into mutable and immutable dependencies, the London school would say that you need to mock everything except for immutable dependencies. So all mutable dependencies should be mocked or replaced with mocks. For example, if you are writing a user class and that user class has a dependency on a company class, which is also mutable, then in your tests, you need to replace the company class with a mock and test the user class in isolation from that company class. That would be the London school. And the classical school would be, so if we subdivide mutable dependencies further into in-process and out-of-process dependencies. So for example, in-process mutable dependency would be that company class, and out-of-process mutable dependency would be a file system, a database, or a third-party API. The classical school would say that you need to only mock out-of-process immutable mutable dependencies, like the database or the third-party API. And you shouldn't mock the in-process mutable dependencies. You need to just basically test your system under test with the real instances of those dependencies. That's also, that's the gist of the differences. And my personal opinion that both are incorrect. Both schools are incorrect in their treatment of mocks. And we can actually talk about why. So the London school is incorrect because if you are replacing communications with in-process mutable dependencies with mocks, you're basically introducing coupling to implementation details in your tests, because how your user class communicates with the company class, how exactly that class communicates with the company, is an implementation detail. It doesn't, from the end user perspective, the only thing that matters is the end state of the user class or your system as a whole. It doesn't really matter for the end user through which communications or through which connections your user class went to achieve or to end up in that final state. So the final state would be the thing that we need to check here, not the communication pattern between the user and the company class. And when you do check that communication pattern, let's say you test that the user called a specific method on the company class, then it means that you introduce implementation details, because the specific communication between these two classes is an implementation detail, and it may change during refactoring without changing the observable behavior of the system. So let's say you could refactor your user class so that it doesn't actually call that company class, but it does the same thing in some other way. So you could modify that behavior, refactor that behavior without modifying the observable behavior, and your test will raise a false alarm because it expected that communication between the user and the company class. So that's the reason why the London school is incorrect, because communications between in-process mutable dependencies are implementation details. And the classical school is also incorrect because not all out-of-process dependencies should be mocked out. So it basically doesn't, the classical school doesn't make a distinction between out-of-process dependencies. It says that all out-of-process dependencies, like the third-party API, the file system, or the database, should be mocked out. And that's also incorrect because from the end user's perspective, let's say you have an API and you have a user of that API, what users of that API see is also the end state of your API application. They don't actually, if they don't have access to the database behind that API, they cannot actually observe that database, and that database essentially becomes part of your API. So basically, you need to differentiate between out-of-process dependencies that are visible to the external world and out-of-process dependencies that are not visible to external world. And the database is a good example here because a database, an application database, is something that is not visible to external users. It's part of your application, of your API, and other users can only access it indirectly through your API. And because it's not visible, you can actually modify the way you communicate with that database without, you also can modify it without actually changing the observable behavior of your system. So you can, let's say, change or even replace your relational database with a NoSQL database, and it wouldn't affect your customers as long as you keep the behavior intact. It wouldn't affect them in any way. And because of that, you shouldn't actually mock the communication pattern between your application and that database because it's not part of the observable behavior. And if you do that, if you mock that communication pattern, then you also tie your application to implementation details. And that may change over time. So the only type of out-of-process dependencies that you need to mock in tests are those that communications with which are visible to external world. So let's say, for example, if your application puts messages on the message bus, that kind of out-of-process dependencies should be marked out because communications with that message bus are visible to external world. Regardless of the refactorings that you do in your application, the way your application communicates with that message bus should always stay in place because otherwise, if you change the way you communicate with that message bus, the applications that depend on your application would stop understanding your messages. So if you just change the format of your messages, other applications or other downstream applications would not be able to understand those messages anymore because they expected the old format. And because of that, it makes sense to mock those types of dependencies because you need to make sure that communications with them always stay the same so that you don't break the backward compatibility between your application and other applications. But at the same time, you don't need to maintain backward compatibility between your application and the database because the database is part of your application. It's not visible to anything else. And you deploy changes to that database alongside with your application. So basically, from the perspective of the end users, your application and that database are a single system. They are not separable. And in the book, I basically subdivided that type of dependencies, those out-of-process mutable dependencies, into two subcategories. The first one is managed dependencies, and the second one is unmanaged dependencies. And a managed dependency is a dependency communications with which are not visible to the outside world. So basically, it's fully managed by your application. And database would be a good example here. If no other applications can peer into that database, then it's a managed dependency and it shouldn't be mocked. Whereas unmanaged dependencies are out-of-process dependencies, communications with which are visible to the outside world. That a good example here would be a message bus because you put messages on the message bus and they are visible to the external world, because that's basically the main purpose why you do that. You put messages there so that other applications can read those messages. So yeah, the difference here is that you should mock unmanaged dependencies, but you shouldn't mock managed dependencies.
Yeah, Vlad, thank you for this thorough answer, I would say. And you also answered my next question. Basically, should we mock and when should we mock the database also? So I'll just skip that one.
Well, there are some exceptions actually to this rule,
Mhm.
because, as I said, you shouldn't mock the database when this database is not visible to the outside world. But there are cases when, for example, there are multiple applications that look into the same database. And in this case, this database becomes not managed, but unmanaged dependency. And so in this case, what you can do is you can separate the parts of the database that are visible to the outside world from the parts that are not. And you can treat the part of the database that is visible to the outside world as an unmanaged dependency, and you can mock that part. But you can treat the other part as a managed dependency, and you shouldn't mock that part. So you need to be specific and careful as to how you treat your database depending on the access patterns for that database.
Yeah, I completely agree. Okay, and I would also like to hear like maybe what do you have to say about some common anti-patterns when it comes to testing that you came across in your career? Maybe some interesting ones.
Yeah, the most prevalent anti-pattern is coupling your tests to implementation details of the system under test. And that's the thing that a lot of people do, and even without realizing it. So mocks is a good example here, because if you overuse mocks, then your tests become brittle, they break all the time after changing implementation details. And the reason for that is, as I said, is because your tests couple to implementation details as opposed to the end user, to the behavior as it's seen from the end user's perspective. So that's the general guideline. And there are a lot of common anti-patterns that flow, that can be categorized as this anti-pattern, but with different flavors to them. So for example, you could, as a developer, you could test, let's say, private methods. That's another example of coupling your tests to implementation details, because your private methods are implementation details. They're not visible to the customers of your class, and because of that, you shouldn't test them, because you should always test the behavior of your classes, of your system, from the end user's perspective, exactly the same way as the clients of your system view your system. Your tests shouldn't have any special privileges in that sense. And if you test your private methods, it means that you access your system, or you interact with your system under test differently from those end users. So that's a widespread example. Another variation of that is not private methods, but private state. It's also quite prevalent. Basically, you, instead of testing, so basically, let's say you have private state and some behavior that depends on that private state. An example that I gave in the book was if, let's say, you have a customer class and it has the private state called the status. So basically, the customer could be regular status, or it could be of a preferred status or advanced status. And depending on that status, there are different discounts that are given to that customer. So basically, you have the customer class, you have this private state of that customer, and then you have a public method that returns you the discount depending on that private state. And so there could be a method, let's say, advance that customer from the regular status to the advanced status or the preferred status, and you need to test it somehow. So how would you test it? One way is to just test that private state, that it indeed changed from the regular to the advanced status. But the better way would be to, again, to test it from the end user perspective. If the state piece is private, it means that the user, the client of your class, doesn't really care about that state. What they care about is the public part of your methods. In our case, it would be the get discount method. If it's public and the state is private, it means that the customers only care about the discount and not the state. So in the test, you also need to follow the communication, the interaction pattern as well. Basically, you need to mimic the end users, the clients of your class. You, instead of testing the status, which is private directly, you need to check what discount is returned when you promote the customer to the advanced status. That's another example of coupling your tests to implementation details. Another way would be to leak the implementation details to the tests. And that's when, for example, you have some complex functionality or some complex algorithm. And in your tests, you basically duplicate this algorithm, you embed it into the test itself, and then verify that the result that the production code generated would be equal to that value, to that number, let's say. That's another anti-pattern because you're basically copying the code or implementation from the production code to the test code. You shouldn't do that. The proper way to just hard code the expected values. That would be much easier and better to do because otherwise, yeah. So basically, the guideline here is that you shouldn't copy implementation from your production code to the test code. And there are some other anti-patterns. So basically, another anti-pattern that is not related to coupling your test to implementation details is when you make your tests too complex or too complicated. That's also an anti-pattern. Basically, if you have any if statements in your tests, or even maybe for loops, although there are some exceptions, but generally you shouldn't have any logical or any if statements or this kind of logic in your tests, because it means that your tests don't actually test one thing. They test some multiple things. If you need to test different things, just create two tests. So instead of introducing if statement, you can create two tests for each of the branches of that if statement. That would be much better than to overcomplicate the tests themselves.
Yeah, I have to agree. Like the third one that you mentioned, basically testing multiple cases or something, that is the most common one that I came across. Yeah, okay. So I have one more question regarding the testing topic. So maybe to basically to close it out. So maybe can you tell us what's your vision for the future of software testing? Like where does it go from now, or like what's the new thing that's coming?
Well, I'm not sure if you're hinting at AI, like artificial intelligence, or not.
A little bit.
But I'm not well versed in that topic, so I'm not really sure what would come out of that in terms of testing. How I see it is, I just hope that people would take these principles to heart, and instead of just coupling tests to implementation details, as a lot of us do, and I did myself in the past as well, we just try to verify the functionality from the end user's perspective. That's one of the main points of the book, and I did a lot of different elaborations on that point. It's not the only one, but it's one of the main ones, I would say, just because it's one of the most spread anti-patterns that I encounter in my professional life. I just see people doing these things over and over again, and that was one of the reasons why I wrote the book.
Yeah, I have to agree on this one as well, since basically we as developers, we need to, if we have a good relationship with the core principles, then we don't have to worry about the future and some other things that are coming up in software testing. Okay, so when we talk about software testing, we have to mention one more subject, and that's test-driven development. Can you tell us a bit more? What is test-driven development, and why should we use it or not use it?
Yeah. So test-driven development is basically you can write tests in two ways. You can write the code first and then write the test after that. Or you can first write the test, specify what you need from the code, and then implement the code in such a way that the test that you've written passes. So these two approaches are called code first and test first approaches. The usual way is the code first, and the test-driven development one is the test first approach. The difference is that, well, I would say that you need to do both, and the difference. So when exactly you should prefer one over the other is when you're just starting out the project and you're not sure what exactly it should do or how you should implement that project, or maybe you're not sure about the overall model or domain model that you are going to use or write in your project, then you need to just play around with that, just maybe do a little bit of prototyping, just write some code, scratch it, write another version. So in this scenario, in this setting, tests would actually hinder this activity, and you shouldn't write tests maybe even at all, or at least you shouldn't write them before your code, because you don't really know exactly what you want to write. And by actually writing your code, you explore the potential possibilities of how your architecture or how your domain model would look. But when you wrote some code and when you become pretty sure of how your code or domain model will look like, then you can switch to the test-first approach. And it's beneficial because with this approach, you can actually test not just the code itself, but also the test that covers that code. And that's the whole point of this test-first approach, of the test-driven development, because when you write your test, you see that this test fails. So how you should approach that? First, you write the test that is failing, then you verify that it fails for good reasons, and good meaning that it doesn't fail just because you forgot to let's say add some variable or assign some input value. It fails because the functionality that that this test expects either wasn't written yet, or it is written incorrectly. So basically, your test needs to make sure that you need to make sure that the test fails for that exact reason, not some unrelated reason. That would be the second step, making sure that the test fails for a good reason. And then the third step would be to actually implement this functionality or to fix the incorrectly working code. That step would make your test green. And after that, you can refactor your code so that you can basically simplify it, or maybe reshuffle some bits and pieces so that you make the code clean. And your test will help you ensure that this fourth step, this last step, is successful, because with the test you can be sure that you didn't break anything. So the second step is important. The second step, which is making sure that the test fails for a good reason. As I said, it's important because this way you are verifying the test itself. You're making sure that the test will fail if this functionality stops working. And if you don't write your test first, if you write your test after you wrote the code itself, then in order to test that test, in order to verify that test, you need to after you implemented the code, you need to actually undo the implementation, or maybe comment out some lines inside of it to intentionally introduce a bug to make sure that the test catches that bug. Because otherwise, you don't know if your test actually works, because it may just be a false negative when your test says that everything is fine, but in reality, the code may not be working. So just to make sure that the test doesn't generate any false negatives, you need to introduce the bug into the production code, make sure that the test catches that bug, and then revert the production code back. So instead of doing that, you can just write the test first before the production code, and then make sure that this test verifies all the important pieces, all the requirements. So that's one of the main benefits of test-driven development. And another benefit of it is you can actually view it as the specification of the requirements that your code should do. So what I usually do when I let's say I know that I need to do what functionality I need to write, I can come up with some requirements for that functionality. Let's say the tax calculator generates proper tax for, let's say, for a couple of orders, and then I come up with some edge cases. Let's say that I am in another tax jurisdiction, or I'm a special type of customer that has a lower rate of taxes. So stuff like that. I come up with all those specifications, all those requirements, and you can specify them not just in writing. I mean, not just on paper, but in form of those tests. You can actually write them down as separate specific tests, and then implement them one by one. Ideally, you would also write the tests themselves, but if you are not exactly sure how exactly you need to do that, you can just write the names of the tests that would capture those specific requirements with maybe just and make them fail. Just I can write assert.true or assert.fail even. So they will always fail, and that would be a reminder for you to not forget to actually implement those tests and the functionality that those tests cover. So this is also a good routine when you first specify the requirements that you want your code to implement, and then specify it in a form of tests, and then after that you can actually implement those requirements, and that's also I would say it's a good way to document those requirements.
Yeah, Vlad, I assume that you worked on at least a couple of projects that were following TDD. So what would you say that were like challenges for everyday developer, like following the TDD throughout the long project? Were there any, or like were just like any other design principle?
Well, I would say if we are just comparing TDD or test first with the code first approach, the most significant difference between them would be to just wrap your head around this approach, because it's not actually easy to do that at first when you're not used to this approach. Writing tests before you even have a code, what's that? It's not the common way you think about that. So the most difficult part here could be the getting used to that approach. Another thing would be to have the code that's not easily testable, but that's also a challenge for the code first approach as well, because if you write code and then you write a test, then you also have challenges of how to test that code if that code doesn't have proper separation or proper seams between the logic and the out of process or external dependencies. You cannot actually interject properly into that code to test somehow, somehow. So yeah, if we're talking about testing in general, I would say the challenge is to have a testable code itself. And if we're talking about TDD specifically, the challenge is to just get used to this approach, because it's not intuitive at all.
Yeah, I talked with my colleagues in the past couple weeks, basically on this subject, and they had uh, the same thing to say. They said like the sorry, I lost the word. So basically, they said that the toughest one was to change the mindset to writing tests first, even though the code doesn't exist. But that challenged them to challenge their PM or PO to write better, let's say, tasks in Jira or any other tools. So basically, that mindset needed to be changed, and it took a couple of weeks. But later on, they were like more efficient in doing it.
Yeah.
And yeah,
Yeah,
and
couple of weeks. I would say it's a good period to get used to it. So it matches my experience as well.
yeah. Okay, and also like the next logical thing to talk about when we mention TDD is domain-driven design or DDD. So what do you have to say? What do you have to say about that?
Yeah, another topic completely. I don't think we will be able to cover it in the rest of this
Yeah,
meeting.
can we
But
can we spend at least like 10 or 15 minutes just talking about this since it's really important? I'll mention later on why if that's not a problem.
yeah, sure. So
Yeah.
the main, I would say, the main purpose of domain-driven design is to shift the focus of developers from technical things or technical aspects of the application to domain aspects or to business logic aspects. In the past, I'm not sure how it is now for people who just start out their development career, but when I started out, uh, what most developers did is they didn't really care about the business logic or domain logic. They mostly cared about technical things like the database, how good this specific database is, how you can write a query that is faster or better or more performant than another query, or maybe some patterns. I don't know, some multi-threading. While it's also important to understand all those technical concerns, when you write your application, you actually the first thing that you should focus on is the business logic of that application. That's what you need to spend the most time on. And those other technical concerns, they are also important, but they come second after the business logic part. So that's for me personally, it was actually revelation, I think the word, when I read the blue book from Eric Evans. The revelation was that you actually need to spend time on the business logic, because before that it was just an afterthought. It's just some code that maybe comes with your stored procedures, or maybe you put some of that in your controllers, or WCF handlers at that time. So you just thought of that separately. First, at least for me, it was the case. I thought first of the database, of stuff like WCF, of some integrations maybe with other systems, whereas you should completely revert your mindset and think of the business first. So that's what I call focus on the core domain. That's one of the things that domain-driven design teaches us. And another thing is communication with domain experts or business people. To actually have productive communications with them, you first of all, you actually need to communicate with them. But the second thing is, and I'm mentioning that because a lot of times you see that developers don't have access to domain experts, or they don't communicate with business people at all. They should have at least some communications with them, because it's important for developers to understand what they are writing, not just implement some specifications that business analysts give them. That's the first thing. The second thing is that in order to facilitate that communication, you need to use a common language with them. And the blue book by Eric Evans called it Ubiquitous Language, but you can just view it as business language, the language of the business people. So to facilitate the communications with them, you also need to use the same business language, the same ubiquitous language that those business people use, because otherwise your communication will be quite you wouldn't be able to communicate with them properly, because you will just experience communication barriers along the way. You will have to translate the terms from your programming language or your application code to the terms that these business people can understand, and then back again. Yeah, these I would say the most important things that the domain-driven design teaches us. There are some other technical aspects or maybe tactical patterns, but the most strategic ones are these ones.
Yeah. So, before you answer this, I mentioned that this subject is really important for me and the company as well, since the past couple of years we're trying to be like not only like technology partners or like a service-based company. We're trying to be actually a business partner to our clients to provide some additional value, not just write code and focus on technical stuff. So this is really important, and we are working on that. We are working on like preparing colleagues for the domain itself, not just for the technology that's being used to develop a project.
Yeah, exactly. You can think of it this way. You shouldn't be just a code monkey. You also need to be an actual partner for the business. Even if they don't view it as such, you yourself should view it as a partnership where you can not just write the code for the client, but also advise them as to how exactly their business maybe could work differently or stuff like that. So basically, when you try to encode the business logic into the actual code, put it in action, you will see some inconsistencies here and there, and it's always good to communicate those inconsistencies with the business people and have a little bit of back and forth with them to flesh out the details, to see what exactly they meant or how exactly this should be implemented to best serve the business needs. So think of it this way. You shouldn't just have a mentality of give me a spec and I will implement it. That's what compilers for. You're not a compiler. You are a person who can actually provide business value for the customer.
Yeah, and I would say that that's hard because most of the developers were taught to think like in engineering way, just to solve the problem and not to go out of the box. So I would say that mindset needs to change. Like developers need to get out of the comfort zone and think like of the business like the whole business, not just the technical side. So yeah, but as I said, we are working on that, and I would say that every developer needs to involve that business mindset throughout their career in order to advance in the career.
Yeah, exactly.
Okay, so uh, there are many components of domain-driven design and like the parts that consist of it. So I would say that bounded context is one of the most important ones. I would say. So what were the challenges when you're trying to define the context and like how to separate things itself?
Yeah, bounded context is another strategic pattern in domain-driven design, and basically the idea is that you need to have, well, you shouldn't have all the, let's say it this way, if your application is big or large, you need to split it, and you shouldn't have just one model that addresses all the needs of the enterprise. Let's say you're developing an ERP enterprise, basically a big system that automates a lot of stuff. You shouldn't actually have just one single model that addresses all those business needs, because there are a lot of them, and they even may be contradictory to each other. So, let's say in one context, you may need to focus on one aspect of the business, whereas in the other context, you actually don't need to pay that much attention to that, and you can just treat it as an afterthought, and you need to pay attention to another aspect. So you need to explicitly outline all these details in your code by separating them into separate what's called bounded context. And the bounded context, you can think of it basically you can think of it as a separate space where you are solving one problem for the business. And that's a context where your domain model should be consistent and should focus on one thing. So a good example that Martin Fowler also provides is, let's say you have a company that sells some software, and you may have a sales bounded context that is focused on the sales part of the business, and then you can also have the support bounded context that's focused on the support side. So when the software is already purchased by the customer, and the customer needs some hand-holding along the way, some support along the way. So these are two pieces of your software. They are both important, but they focus on different parts of the business. One for the sales, and the other one for the after-sales activities.
Yeah, and now when we separated the context, now we have the communication between the context and also the communication between developers and the business people, or stakeholders, or anybody that's not a technical person, I would say. So and then we come to ubiquitous language. Like that's the principle that's commonly mentioned in DDD. So what's your opinion on that, and how does ubiquitous language helps developers understand the business and the communication between contexts as well?
Yeah, that's the business language that I mentioned earlier. So basically, each bounded context should have a separate model, and this model is expressed with this ubiquitous or business language. And you can think of, basically, this is the separation. Each bounded context can have their own version of this ubiquitous language that's focused on the things that this bounded context cares for. And the same for the model. So basically, the domain model should also be expressed in the same ubiquitous language, and it should also focus on those specific things. Those bounded contexts can communicate with each other. Usually, when in this, for that example, with the sales context and the support context, you may have both contexts could have a customer entity, or it could have, let's say, let's say it's a customer entity. But the focus would be different for these contexts. So the sales context would focus on how exactly to make a sale for that particular customer, and the support context will have the focus on how exactly to make that customer happy when they use the purchased software. As I said, different things, different goals, different models, and different ubiquitous languages.
Yeah. Okay, Vlad, since we are unfortunately running out of time, I believe that we could talk about TDD and domain-driven design and the rest of the design principles for hours. So we'll have to basically stop it here and leave to our listeners to go and explore on their own. Thank you for all the thorough answers, and thank you for being a guest in our podcast.
Yeah, thank you for having me.